Good morning, everyone. Today, I will be presenting how computational thinking, or CT, will integrate across two connected projects that involve an applied activity and a plug-in scratch activity, both built around the same big science idea that are ecosystems and food waste. I will walk you through the objectives of each project, how the five city skills will apply in each one, and finally, why this kind of integrations matters for both teachers and students. In these presentations, we are integrating the computational thinking in science problem solving from unplugged to plug-in. They are involved two projects. Project 1 is unplugged activity that titles Who Will Survive. Project 2 is Scratch Game that titles Save the Forest. I will structure these presentations in four parts. First, the objective of both projects. Second, how each of the five city skills like decompositions, pattern recognitions, abstractions, algorithm, and evaluations appear concretely in each project. Third, how the two projects connect as one learning progressions. And finally, the benefits of this city integration for teachings and learning. In this slide, we are going to see about the objective of Project 1. Project 1 is called Who Will Survive. That is an applied activity designed for upper primary students, year 5 and year 6, down in the groups of 4 to 5 students using visual card and string. The scenario is simple but powerful. A species disappears from the ecosystems and students must predict what happens next. The science objective is for students to generally understand food chains and food waste, but not memorize that, and to explain the ecological barrier using evidence. The city objective is to have students apply all five city skills to hands-on, screen-free reasonings. This matters because students very often memorize food chains as isolated facts without understanding how organisms depend on each other. This activity was designed physically to fill that gap. Project to save the forest, it tests the same ecosystem concept but move it into a plug-in and digital environment using Scratch. Here, a factory has been secretly polluting the forest with smoke, poisoning the waters and screening the glasses. The player characters, the explorer, must investigate the food chains, check how this damage, breast, and choose the correct solutions before the forest is lost. The objective was not to teach a new science topic, but to apply the same city's thinking process in a more dynamic and consequence-driven format. Every decision the player makes, like sorting correctly, clicking the right organisms, choosing the right solutions, will affect a life health variable that representing the ecosystem's health, which will ultimately determine whether the game ends with a healthy forest or a dead forest. That branching outcome is what pushed this beyond a simple digital quiz into a real interactive problem-solving experience. Let me now go through how each city skill was made concrete in Project 1. For decompositions, the students physically saw the organisms called like glasses, grasshopper, fork, and snake into ecological categories. This matters because students cannot analyze a whole ecosystem all at once. They need to first break it into manageable parts. For pattern recognition, students compare two different food chains side by side and identify recurring patterns. For example, every food chain begins with a producer and primary consumer always feed on producers. Besides, for extractions, when the teachers announce that the rabbit population has disappeared, the students need to examine the complete food waste by highlight only the organisms connected to the rabbits like grasses and frogs, while ignoring the organisms that were not relevant to that specific province. For algorithm, students allow a six-step logical sequence that involve identify the remote species, trace connected organisms, predict direct effects and indirect effects. Then the students also need to explain the reasonings and record their answers. For evaluations, the answer records need to present to the classes and compare their answers with the other groups. They need to justify their reasoning using evidence from the food waste, while the teachers facilitated the discussions toward the scientifically correct conclusions. In this slide, we are going to look at the city integrations in Project 2. First, decompositions. Students are required to classify the spikes such as grass, rabbit, fox, eagles, and factory into the correct categories. Then, pattern recognitions. They need to arrange the food chains in the correct sequence. For examples, grass followed by rabbit, and then fox, and then eagle. The assertions also require students to identify only the organisms directly affected by the pollutions and ignoring the indirect effects. Furthermore, the algorithm student requires to arrange the chance of the ecosystem changes from grasses drying to the eagle livings. Then, evaluations. Through a decision quiz, students choose the best solutions. The correct answers while improving the forest health, while the incorrect choices will reduce it and provide the feedbacks. All decisions will affect the one health variable, leading to neither of healthy forests or dead forest endings. It made the students' computational thinking visible through the gain outcome. For unplug to plug in, the connections, we are going to look at the differences between Project 1 and Project 2 and also their connections. Project 1 is an unplug activities that requires students to explore the food waste and involve in physical discussions to build city through collaborations. In Project 2, we are asked students to have a question that apply the footway knowledge and interactive digital problem solving. This aims to help students can and reinforce cities through gameplay. In these pictures, we can see unplugged activities involve the cast and the physical discussions, and plug-in activities involve the gameplay. So, what I want to highlight here is that Project 1 and Project 2 are not unrelated tasks. They are a deliberate progressions. Both are built on the exact same science concept, food waste, and ecosystem balance, and both require students to apply the exact same five city skills. What changes is the mode of thinking students engage in only. In the unplugged activity, CT is scaffolded through physical manipulations and group discussions, with the teachers facilitated the evaluations. In the plug-in activities, CT is scaffolded through a digital environment while the feedback is immediate and evaluations is tied directly to the consequence the students can see. The ecosystems health rising or falling in real time. And ultimately, two very different endings depends on how well their reasons. These progressions moves students from concrete, guided reasonings to more independent, consequence-based digital reasonings, while they were never letting go of the same underlying CT process. Integrations of CT is important for students as the city skills are able to help students to have a deeper understanding of ecosystems. By applying these five city skills, they are able to move beyond memorizing facts to solving problems step by step. Completing both the unplug and plug-in activities are able to reinforce students the sense thinking process in different ways, improving understanding and retention. In the scratch games, immediate feedback through the help bar, changing factories, and different ending also keeps students engaged and encourage their self-corrections. More importantly, students develop the transferable skills such as logical thinking, pattern recognition, consequences, and evidence-based decisions making that shall be applied beyond science. For teachers, this is one reusable city framework that works in both apply and plug-in lessons depending on the available resources. The both projects also support formative assessment. In Project 1, teachers can identify the misconceptions during discussions and guide students to improve their reasoning. In Project 2, the score and health variables provide the instant feedback without the extra markings. The unplugged activity is low cost and easy to implement, while the Scratch can extends to send lessons digitally, that giving teachers flexibility to use neither or both. In the key takeaway, from unplugged to plugged, both projects teach the same science concepts using the same five computational thinking skills. The students first develop their reasoning through a hands-on activity, then apply it independently in a digital grant. This approach strengthens the understanding, engagement, and problem solving, while teachers with a flexible and reusable teaching frameworks. Before designing these two projects, I aimed to help students to understand ecosystems through active problem solving rather than simply memorizing food chains. After comparing both activities, I found that each approach offers different strengths. The unplugged activity encourages collaboration, discussion, and scientific reasoning. The students were able to manipulate the organism cards, explain their predictions, and justify their answer using evidence from the food web. This helped me identify the misconceptions immediately through classroom discussions. The Scratch activity extended the same learning into a digital environment. The immediate feedback through the help call, hints, and different game endings motivate students to reflect on their decisions and correct their mistakes independently. Instead of waiting for teacher feedback, students would learn directly from the sequence of their actions. However, I also identify several areas for improvement. For the unplugged activity, I will include more decision checkpoints to help students verify their reasoning before making predictions. For the scratch game, I will introduce multiplies difficulty levels and additions ecosystem scenarios so that students can continue developing their computational thinking skills at a more challenged level. Overall, this project has shown me that unplug and plug-in activities should not be viewed as separate approaches. When carefully connected, they complement each other and create a meaningful learning progressions that develop scientific understandings, computational thinkings, collaborations, and digital literacy.